G'day and welcome to this video on sketching quadratics using the turning point method. For this video I want to show you how different things can happen to a quadratic graph. We call them transformations, and the three types of transformations that can occur are dilations, reflections and translations. And I'm going to describe each of these three as they are applied to a graph. The way that I'm going to do this is I'm going to look at this method, or this version of the graph, so when it's in the turning point method like this, and I'm going to show you how changing A, H and K actually affect the graph. We've had a look at a little bit of H and K in a previous video, but I'm going to sort of tie it all in together now. So A at the front here is the dilation of a graph, or A can affect the dilation. And that means that the graph will either be, fatter or skinnier. What I really mean by that is that that A can actually stretch the graph this way and this way, making the graph look either fatter or skinnier. Okay, there's actually two types of dilations when we look at year 11 and 12 maths. Sometimes you can actually dilate it this way as well, and we say that's from the y-axis, but in year 10 we're just going to look at from the x-axis. So A is the dilation, and it makes the graph either fatter or skinnier. Let me show you a couple of examples just here. Y equals x squared is the thing I'm going to compare it with, and now I'm going to make the dilation a factor of 2, from the x-axis. And so this is, if I draw this graph, if I substitute x as 1 into this, I'm going to get 1 squared, and so when x is 1, y is 1. When x is 1 over here, it's 1 squared, then multiplied by 2. So in fact, every single x value on this graph, when I substitute it in, will be the same x value as on this graph, except this graph has been multiplied by 2. Every x value is multiplied by 2, so therefore the y value is doubled. Okay, so that ends up being, instead of being along here, the black line, it ends up being the red line here, because I've stretched it away from the x-axis, so it looks like it's a little bit skinnier. Okay, so instead of the point being here, it's now up here. Instead of the point being here, it's now doubled up to there. Okay, and my scale on the graph isn't very good, but hopefully you can see what's going on. Now, if A is a quarter, for instance, it means that after I substitute the x value in, I'm going to multiply it by a quarter. So it essentially means that every y value is now a quarter times as big as it was before. So instead of being along here, it's actually now a quarter of the size. Instead of being there, it's now a quarter of the size. So this one looks a little bit, fatter, if you like. It's been squashed towards the x-axis this way. So A has an effect on whether it's, wide or narrow. I can tell you that if A is bigger than 1, then it's narrow, like this example just here. And if A is between 0 and 1, it ends up being wide, like this. Okay, so it's been stretched, when A is between 0 and 1, it's been squashed, and when A is greater than 1, it's been stretched. Okay, so every graph always has a dilation, but a lot of the time the dilation is actually 1. But sometimes the dilation can be bigger than 1. So this is a dilation by a factor of 2 from the x-axis, and this is a dilation by a factor of a quarter from the x-axis. Okay. Another thing that can happen to a graph is that it can be a reflection. Sometimes A is actually negative, and this makes the graph turn upside down. So if I have a look at an example, y equals x squared. If I get y equals negative x squared, so the A in fact is negative 1 in this case, I get the identical graph, and it should actually be identical. I should have drawn it identically, except rather than being a smile, it's a frown. Okay, so it actually reflects things around the x-axis in this case. Okay, so that's dilations and that's reflections. The last one is translations, and we've sort of looked at this a little bit before. But if I have it in this point here, the reason it's called the turning point form is because the turning point is going to be this value here, well, the opposite of this value here. So if that's negative h, then the x value of the turning point will actually be h, and I'll show that a little bit later. And this value over here, the k. So the turning point, the maximum or the minimum point for this graph will be hk. And this can be proved by using the completing the square method, or I guess you can just believe me. So have a look at this one here, x minus 3 squared plus 1. The turning point will be positive 3 and positive 1. So whatever that was there, and the opposite of that one there. And so this graph, instead of being here, y equals x squared, is that one, it's been moved up 1 and across 3 to the right, and therefore it looks like that. Same shape of the graph, but a different position of the graph. I don't need that one there. Let's have a look at another one. X plus 2 all squared minus 1, so minus 2, it's been moved to the left 2 and down 1. So same shape, different starting point. I probably should have labelled that one as -2, -1. Okay. So notice that the h is the opposite and the k is the same as it is. So here, for this one here, x minus 3 becomes +3 and +5. -4, +1. +7, -5. So that's maybe just like a little summary for you, is that A dilates the graph, kind of makes it fat or skinny, or stretches it or squashes it. And if A is negative, the graph is upside down. And H, or maybe I should say negative H, is the x value of the turning point. So the opposite of whatever that number is in there is the x value of the turning point, and K is the y value of the turning point. So hopefully that has helped you understand dilations, reflections, and translations. The only other thing I'll say is that when you're stating the transformations that have happened, they must go in this order: dilations first, reflections second, and then translations third. And I can explain that to you at another time. Thanks for watching this video. I hope that's helped you to understand a little bit more about sketching quadratics and the turning point, and understanding how each number, or each letter in this case, can affect the graph. So thanks very much.